Hey 3M, we're on Unit 5, Lesson 2, and we're continuing with powers. We're going to just use a couple power rules to simplify here. We have 4 cubed divided by 4 cubed. And when I am looking at a division, my first thought is, do I have the same base? And I do. Both the numerator and the denominator have base of 4. So I can use my rules of powers, which would be keep the base, subtract the exponent. 3 subtract 3 is 0. Well, that's kind of weird. I also know that 4 cubed is 64. So I could rewrite that question as 64 divided by 64, which I know is 1. So strangely, it looks like 4 to the 0 is the same as 1. The second one I have is 4 cubed divided by 4 to the 5th. My rules for division would be keep your base, subtract your exponent. 3 subtract 5 is negative 2. But I also know that 4 cubed is 64, and 4 to the 5th is 1024. Okay, so that's just weird. So I'm going to divide out 64 top and bottom, and I will get 1 over 16. It appears that 4 to the negative 2 is the same as 1 over 16. Crazy. Let's look at that pattern we were looking at last day just a little bit further. If we have 2 cubed, we know that that means 2 times 2 times 2, which is 8. If we have 2 squared, it means 2 times 2, which is 4. If we have just a single 2, 2 to the 1 is 2. As we're going down the table, we are having 1 less 2 each time, so we're dividing by 2. 1 less 2, dividing by 2. So that it would follow that 2 to the power of 0 should be 1 for this pattern to make sense. And math is all about patterns. Likewise, if I am dividing by 2 as I go down the table, 2 to the negative 1 should be 1/2. 2 to the negative 2 should be 1/4, or 1 over 2 squared. So I can see that my negative exponent makes a fraction. It inverts that 2 and flips it upside down. So we've got negative exponents which flip things, and we have a 0 exponent which is 1. Actually, I'd like to just go back and we will write rules in your table. So that summary table that you have, that we were filling in yesterday, can we make sure that we have the 0 exponent rule? If you have 2 to the 0, it's 1. If you have 1037 to the power of 0, it will be 1. Anything to the power of 0 is 1. If you have a negative exponent, gets a little tricky. If you had 2 to the negative 3, we didn't quite go that far, but your negative exponent says that we're inverting because we're dividing by 2 yet one more time. And my answer would be 1 over 2 cubed. If you could also put on to our summary table something like 2/3 to the minus 4, that negative exponent says to invert, we would have 3/2 to the power of positive 4. So my rule, algebraically, let's write it as the fraction a over b. If we have it to a negative exponent, that negative exponent says invert or flip it and make your exponent positive. Let's try a few together. 4 to the negative 6 means 1 over 4 to the 6, which is 1 over, and I am ashamed to say that I have to use a calculator for that one. It is 4,096. They get big, or actually in this case very small, quickly. Negative 3 to the negative 2. Oh no. So I've got a set of brackets. That means the negative 2 is affecting the whole bracket. So it's going to be 1 over, because I got to flip it. My base is negative 3. and my exponent is now positive. There's also a 2 with that 1 on top, but you don't have to write it because we know that 1 squared is the same as 1. So negative exponent, you could just write it as 1 over negative 3 to the positive 2. 8 to the power of 0, anything to the power of 0 is 1. Awesome. 7/3 to the power of negative 5. That negative exponent means invert or flip, and then you have a positive exponent. To simplify that a little further, we have power of a quotient, which means it's 3 to the 5 over 7 to the 5. Those numbers are so big, I would just leave it. The last one here, I have 1 over 8 to the negative 2. That negative exponent says flip or invert. It's already on the bottom, so now it's on the top. 8 to the positive 2, which is 64. 3 more examples. I trust you're writing them down. Okay. I see some power rules going on here. I have a numerator that has multiplication going on and a denominator with power of a power. But also, nicely, everything has the same base of 5. So I would tidy up the numerator separately from the denominator, and then we'll worry about the division. On the top, I have multiplication. So my rule is keep the base, add the exponents. Negative 4 plus 8 is positive 4. On the bottom, I have power of a power, which states you keep the base, multiply the exponents. Then I have division with the same base, so I may keep the base. My rule would be subtract the exponents. 4 subtract negative 6 is 10. Huge number. Oh, it says simplify and evaluate. All right, 5 to the 10. I don't happen to know that because the answer is 9,765,625. Of course, you probably knew that. All right, 7 to the 0. Subtract 2 to the negative 2. 2 problems with this particular question, different bases, and subtraction. We don't have a rule for either one of those things. So the only thing that we can do is evaluate one piece at a time. 7 to the power of 0 is 1. Anything to the power of 0 is 1. Subtract. 2 to the negative 2 is flip 1 over 2 to the positive 2, which is 1. Subtract 1/4. Final answer, 3/4. Simplify. Write your answer with positive exponents. So I see a lot of multiplication going on. I have a to the 4 multiplied by b to the negative 5 multiplied by, because they're squished, a to the negative 6 multiplied by b to the negative 2. So in this long line of multiplication, I have a's and b's. So I can use the rule, of multiplication. Product rule would be keep your base. So I'm going to deal with my a's first. Add the exponents. 4 plus negative 6 is negative 2. Then my b's, keep my base, add my exponents. I have negative 5 and negative 2 added together is negative 7. We don't like negative exponents. They're ugly. So they've asked us to write it with positive exponents. That means I'm going to flip both the a's and the b's inverted because they have negative exponents. So they're both going to the denominator. I'm going to have a to the positive 2 and b to the positive 7 in the denominator. Final answer.